Hi, I'm here to give you the solutions for week 7 homework for October 8th through 12th, 2018. Use this to help you if you got stuck on a problem or you just want to check your work before you turn it in. Simplify by combining like terms. Like terms are constant numbers that don't have variables, or they could be variable terms that have the same letter. You'll notice that I've marked with circles the two constant terms, negative 15 and negative 19. Those are like terms, so I'm going to combine them to get a total of negative 34. My variable terms are 6x and negative 20x. When I combine those, that gives me negative 14x for an answer of negative 34 minus 14x. Number 2, we want to solve the equation. In this equation, all of my variables are on the left already, so I need to eliminate the constant term from the left and move it to the right. Eliminate it from the left. That means make it go away. 8 minus 8 will put it to 0, so we're going to use that inverse operation of subtracting 8. That leaves negative 2x is equal to 10. And now I need to divide by the coefficient of x, negative 2. So divide both sides by negative 2, and you get x is equal to 5. Number 3, solve the following. Look at that equation. The first thing we have to do is simplify. And here I have an x and a 3x on the left that need to be simplified. Let's put those together. 3x plus 1 more x gives us 4x minus 10. There, that's better. On the right, we have some parentheses. Let's simplify by using our distributive property and multiplying that 2 across each of the terms. 2 times 2x is 4x, and 2 times a negative 4 is negative 8. Bring down that negative 2. We didn't do anything with it yet. But we do need to further simplify because we have a negative 8 minus 2 constant terms. So 4x minus 10 is equal to 4x. Negative 8 minus 2 is minus 10. Now here, I notice that both sides are already the same. So I know that this is a special solution. But I'm going to go ahead and show you why I know that it's a special solution and why I know what the solution is. When I eliminate the variable from the right, subtract 4x from both sides, it actually goes away from the right and the left. I don't have any x's. I'm just left with negative 10 equals negative 10. This is a special case that tells me that there's an infinite number of solutions because no matter what number I put into this equation, it's going to give me a solution that's true. See how negative 10 is equal to negative 10 is a true statement? That tells us infinitely many solutions. Number 4, translate the figure up 3 units. Translate a figure means to shift or slide, and we want to slide it up 3. So from V, I'm going to go 1, 2, 3 up, and I'm going to do that with each of my vertices so that each one of them has a new position 3 units above where they were. That's a translation. When I finish, I should have an image that's exactly the same. It's just shifted up 3 units, and I do. Now let's look at Tuesday. Tuesday says simplify by combining like terms. Let's look at this. I have a like term here with negative 7x and here with plus 10x. Put them together and they give you 3x minus 2 minus 9y, and that's all I have. So I'm done with that one. There are no other like terms. On the next one, I have 3x minus 8x, which is negative 5x, plus 18 equals negative 17. Eliminate the constant from the left by using inverse operations. That means make it go away. 18 minus 18 is 0, so that leaves negative 5x is equal to negative 35. Divide both sides by negative 5, and you get x is equal to 7, because negative 35 divided by negative 5 is a positive 7. Look at number 3. Solve the following. I have some parentheses, so let's use that distributive property that we used before. Negative 5x plus 7 times x is 7x, and 7 times 4 is 28, equals 3x plus 31. Combine your like terms. Negative 5x Really, Ms. Hicklin? Negative 5x plus 7x is 2x plus 28 equals 3x plus 31. Eliminate the variable from the right. Subtract 3x. Do it to both sides. That makes the 3x go away. You're left with negative 1x plus 28 equals 31. Eliminate the constant from the left. So 28 minus 28 goes to 0, and it leaves x is equal to 3. I'm sorry, it leaves the opposite of x is equal to 3 because of that negative right there. Divide both sides by negative 1, and you get x is equal to negative 3. Can't get it to move. Number 4 says give a rule that would translate triangle 2 to triangle 3. Triangle 2 to triangle 3. So let's ignore 1 and 4. Triangle 2 to triangle 3, if I translated it, if I shifted or slid it, it would never line up. Do you see how I could take it? There's my triangle. Now, if I took it and I just slid it, that wouldn't work, would it? No. And if I turn it this way around my origin, it would actually bring it. Really? Really? There we go. We'll bring it down, right? But it wouldn't line it up. So that won't work either. So I'm going to put it back where it was, or as close to it as I can. So what we really did was we flipped it over. So I'm going to flip my picture over. But if I flip it over an axis, really. Just keep moving the same thing. Let me just get rid of this. Cut. All right, so now if I flip it over, let me change my line color. And I'll look at these, you know, is it equidistant from some symmetry line? So let's make a line of symmetry right here at the x-axis. You see that line of symmetry? Is it equidistant from it? Let's see, 1 point above and 1 point below. So plus 1 away. Is it the same here? It is. What about right here? Yes, they're both 1. Now let's check that vertex at the top. That's 3 units from the red line. And it's also 3 units below the red line. So we did the same thing all the way around. So the answer to this one is that it's a reflection across the x-axis. Okay? A reflection. Now, I'm going to clear this out because it's getting really junky. Whoops. Just kidding. Let me try that again. I'm going to clear it all off so that we can have some space to write some more. We're going to go back up and let's look at Wednesday. Wednesday has this ugly little fraction right there. You see that 2 in the denominator? Ugh, I don't like fractions. I hear kids tell me that all the time. I don't like fractions. Okay, make the fraction go away. Multiply everything in this equation by that denominator of 2, and your problems will be over. It'll make everything easier. Because 2 times 3 is 6, and 6 divided by 2 is 3. Or you can realize that you're really multiplying 2 by the reciprocal of 1/2 times 3. Either way you look at it, you end up with a term of 3x when you distribute. Let's distribute the 2 across the parentheses to the 12. 2 times 12 is 24, but you see that minus? Think of it as a negative 12. And 2 times negative 12 is negative 24. Now let's distribute across to the other side because we have to hit every term has to hit the distributive property. So every term has to be multiplied by 2. And 2 times 24 is 48. That's a lot easier to solve. Now we just need to eliminate our constant from the left. Add 24 because that's the inverse operation. See how it makes negative 24 and plus 24 go to 0. And then you end up with 3x is equal to 72. Divide both sides by 3, and you get x is equal to 24. Number 2, 10x minus 15 is equal to negative 8x plus 21. Eliminate that constant. Oh, sorry. Eliminate the variable from the left side. A negative 8x needs to be added to make it go away. We want to eliminate it from the right. See how those are opposites? So a negative 8x plus 8x goes to 0. That gives you 18x minus 15 equals 21. Now, eliminate the 15, the constant from the left side. Eliminate it. Make it go away. Minus 15 plus 15. Inverse operations. Bring down your 18x equals 21 plus 15 is 36. Divide both sides by 18, and you get x is equal to 2. Number 3, we need to solve the following. So let me get some of this out of the way. Solve the following. We have some like terms to combine. Let's combine those. 8x equals, oh, I see parentheses. Let's distribute. 2 times 4x is 8x. 2 times negative 7 is negative 14 minus 6. So we end up with 8x equals 8x minus 20, because we can put these constant terms together. Subtract 8x, because you have to put it to the other side. You eliminate the variable from the right, and you end up with 0 equals negative 20. That's not true. That's not equal. Whenever you get a false statement and the variables are eliminated, you should say that there is no solution, because this equation really does not have any solutions that work in the real numbers that we studied. Number 4, we need to draw a picture. Since I need to draw a picture, I'm going to add a grid to the bottom. You could use a piece of your graph paper, and we need to plot these points right here. X for triangle XYZ. We need to plot each of these vertices on our graph. And then we need to reflect it across the y-axis. All right, so I'm going to go negative 2, 1, 2, 3, 4, 5, 6. I'm going to go 3, 0, 1, 2, 3. I'm going to go 2, 8, 2, 1, 2, 3, 4, 5, 6, 7, 8. Let me connect my lines. This may not be the prettiest triangle that when I draw it. Let me connect them in red. There we go. So there's my triangle basically. Now I need to reflect that across the y-axis. Okay, so let's mark our y-axis. There's our line of symmetry. So I need to be equidistant from my y-axis. So what I need to do is I need to take every point that is to the left of my axis. This was 2 to the left. I need to go 2 to the right. Okay, so that means that I'm going to change the x value but not the y value. So my new coordinate is actually just going to change the value of x. So I don't have to draw the whole thing. I could actually put x prime is going to be 2, 6. Instead of being a negative, let me clean that up for you. That doesn't look very pretty. Instead of being a negative, it's going to be x prime is equal to, or I could just put x prime is 2, 6. If all I'm doing is changing the x value to the opposite sign, then y prime would be negative 3, 0. You can check it with the graph. I was 3 to the right of that green line, and so I'd have to go 3 to the left to make it flip across the y-axis. Z prime is going to be negative 2, 8, because only my x values have to change. So I didn't really need the picture, but it helped me see what I was doing to get started. So there's the answer to number 4. Now we're going to clean all this up, and we're going to move on to Thursday. For Thursday, let me move this, whoops, I'll move this over for us. For Thursday, we need to solve an equation again. So let's solve this. Do you have any like terms? Yes, right here. 9 plus 2 is 11. And so you have 11 minus 10x equals 1 minus 10x. Subtract your, move your variable from the right side. By adding 10x to both sides. And it eliminates it from the right side, but it also eliminates it from the left side, leaving 11 equals 1. Is that true? That's not true. That's not equal to 1. So, what did I say a while ago? When you end up with a solution that's not a true statement, the actual answer is no solution. No solution. Number 2. Solve and plot your answer on the number line below. I see a fraction right there. See that denominator of 2? Let's eliminate the fraction and simplify the whole equation. If I multiply by the denominator of 2 and make it the whole number, I'm multiplying by the reciprocal, which means that 2 times negative 1/2 will end up being negative 1x. That's why I chose it. I don't want that there. I've got to multiply that negative 2 times everything in my equation though. So we're going to start by multiplying by 2 times 3x, 6x, plus 2 times 5 is 10, equals 2 times 20 is 40, minus 2 times 1/2 is 1x. Now you can write the 1 there, I just don't do it. Now, I need to add x to both sides to eliminate the variable from the right side. That gives me 7x plus 10 is equal to 40. Subtract 10 from both sides to eliminate the constant term from the left. And you get 7x is equal to 30. Divide both sides by 7, and you get x is equal to 4 2/7. Or you can leave it as 30 over 7. Let me rewrite this. It ran off of our screen. So again, from here, we end up with 7x equals 30. Divide both sides by 7. X is equal to 30 over 7. Or you can write it as a mixed number, but you don't have to. And, it's the same as I told you in class. If I have an improper fraction, unless my teacher tells me I have to, especially on a test, especially on those gridded response tests, I do not rewrite it. I leave it as an improper fraction. I'm less likely to make errors that way. So that's whoops, I didn't mean to erase it. So the one I have the square around is the answer, 37ths, or you could write it as 4 2/7. So moving on to number 3, I need to get some of our work out of the way. So I'm going to move that. All right, x is equal to 30 over 7. Back for number 2. Now we're on number 3. Number 3 is a special case. You have x plus 3 over 4 is equal to 6 over 5. Now, you can find the least common multiple of 4 and 5, which is actually 20, and multiply both sides by 20. Or you can cross multiply and get rid of your fractions. So I'm going to cross multiply. I'm going to multiply x plus 3 times 5 and 4 times 6. So 5 times x plus 3 is equal to 4 times 6. Distribute 5x plus 15 is equal to 24. Subtract 15 from both sides to eliminate the constant from the left, and 5x is equal to 9. Divide by the coefficient of x, and x is equal to 9/5. 9, there you go, that looks better. Okay? And then number 4 wants us to give the vertices of a triangle that is half as big as triangle ABC if A is 0, 0, B is 2, 6, and C is 6, 4, centered at the origin. Well, right here where it says half as big, that tells me that this is a dilation. So all I really have to do is line up my ordered pairs. And when you multiply by 1/2, that's the same as dividing by 2. So what I'm going to do is I'm going to come over here and I'm going to say, well, 0 divided by 2 and 0 divided by 2 will produce a new A prime that's still at 0, 0. And if I take B, I don't know where that line came from. Hold on a second. Let's rewrite this. So A at 0 divided by 2, 0 divided by 2 produces A prime at 0, 0, and B, which is at 2, 6, divided by 2, divided by 2, becomes B prime, which is 1 and 3, and C, which is 6, 4, divided by 2, divided by 2, or multiply by 1/2, same thing. C prime becomes 3, 2. So the vertices that we're looking for are these right here. Our new ones that we got by multiplying. A prime at 0, 0, B prime at 1, 3, and C prime at 3, 2.